This one's really quite difficult in my opinion. So we're just trying to get to this. Notice the 343 and the 255 are values that we've been given previously in the question. So we've been given 343 meters per second as a speed. If you change that to kilometers, then you get this number. And if you do the same with the other speed, if you change it to kilometers, you get this number. So that's the clue as to where we're going with this. Now, if we look at this diagram, it's two right-angled triangles. So right-angled triangles are good for trigonometry and Pythagoras. Can't do trigonometry, there's no angles. So we're looking at Pythagoras. So if we want to work out this distance here, we could do d squared plus 10 squared, add them up and square root. And that's actually what we're going to do. So if we look down here, 10 squared is 100, d squared is just d squared, and that's going to work out this distance here. Now, because this is a distance, we know that distance equals speed multiplied by time. We know the speed because this is the sound, so this is the 343. We don't know the time, so we're just going to call this t. Okay, so this distance, we don't know what it is, but we know that distance equals speed times time. So we're just going to substitute that in. And that's got to be squared as well, because Pythagoras. Now, if we move the squared over here as a square root, we get this top bit. So that looks quite promising. So 0.343t equals this top bit. So we're going well. Now we've got to have a think about where this 2d comes from. Now if we look at the top, this d plus this d gives a distance of 2d. And again, distance is speed times time. So what is the speed here? Well, this is the aircraft moving. So the speed of the aircraft, 0.55. And t, again, we don't know it, so it's time. So 0.55 t. So that's our distance of 2d. Fine. What can we do with this? Well, we've got a t hanging around here that we don't know what it is. So we can work out from this what t is. So divide by the 0.55, 2.55, whatever. Put that down here, and then substitute this fraction here. So the 2d goes at the top, and the 0.255 goes at the bottom, and that still equals this. Now we have a fraction, which is... Sorry, I'm pointing at something that you can't see again. Right, so let's go from there. Put that fraction, where that t is there. Okay, so the 2d is at the top, and the 0.255 is at the bottom. Okay, so this came from Pythagoras, and wherever we see a distance that we don't know, we just put the speeds and the times in that we do know. So we've got to here. It's looking quite like this now. So we want 2d at the top, we have 2d at the top, but we don't want this 0.343 next to it. So what we're going to do is we're going to divide that over here. And when we do it, we get exactly what they want, but kind of the other way around, which is the same. We can swap them whenever we want. So that's that one. Right, solving the equation. Let's just go down here. Cool. Right, first thing I did was I saw this square root and I thought, no, I don't like dealing with square roots. So I squared everything to get rid of the square root. So I squared the top, which just meant that the square root was gone. I squared the bottom, which meant that I got a really ugly decimal, 0.117649. I squared the 2d, which gave me 4d squared, and I squared the 0.255, and again I just got a really horrible decimal. I'd rather be dealing with decimals than square roots. Then I got rid of fractions. So the bottom I moved up and multiplied, the bottom I moved up and multiplied, so again get rid of the denominators. So the 0.065, 0.25, this thing at the bottom here, I just multiplied up and times by the 100 and the d squared. So that's that bit. And again you just move that up there. And then you get the d squareds together. So to do that I moved this one over there. So I moved this d squared over there. And then divide by the number in front of the d squared and square root at the end. And yeah, I got exactly 4 pretty much. So that's that one.